Hey, what's up, guys? I am going to talk about problem 14 today from Math 100, and I decided to do that because there was a Facebook question from Laura Lee. So I'm going to do her question. So it says that f prime is continuous, and then they also tell us that f at 4 is equal to 0 and f prime at 4 is equal to 11. Evaluate this crazy limit. All right, so I wrote out a few things in the intuition. So how you're supposed to be thinking about the problem. First of all, whenever we're evaluating a limit, we just want to plug in the x value, or whatever the variable is. In this case, it's an x value here. We want to plug in the value x equals 0 and see what we get, because sometimes it's just, you just plug it in and you get like 4, and then you're laughing. That's fine. In this case, we get, okay, x is 0, so we get f at 4 plus 0 plus f at 4 plus 0. So that's f at 4 plus f at another f at 4, so 2f at 4 over 0. Cool, what's f at 4? Oh shit, it's also 0. So that would be 0 over 0, which means we have indeterminate form. Okay, so that's kind of what I talked about here. So what does this approach as f equals 0? What does f 4 plus 5x approach as f goes to 0? Okay, what does the numerator as a whole approach? We talked about that. Does that mean we have indeterminate form? Yeah, it does. So that's required to use L'Hopital's rule, right? So we've got the conditions, we can use it. That means we should probably try it. Let's try and take the derivative of the top. Let's try and take the derivative of the bottom. And then let's see if that makes things simpler and try and evaluate that limit. Okay. So let's practice taking the derivative of, say, f at 4 plus 3x bracket. So yeah, if you take the derivative of one of these things, so remember that f is a function. We don't know what the function is. They haven't told us anything about the function other than these specific values. It could be anything. It could be like a sine. It could be an x, it could be a whatever, right? We don't know that. Let's pretend, because this is the hard part, I think. This is where I think a lot of students have trouble, because they can do chain rule, people can do chain rule, but they don't recognize that this is actually just the same thing, So let's say it was sine of 4 plus 3x. If it was sine of 4 plus 3x, how would you take the derivative of it? You'd go, oh wait, that's for sure a chain rule. I would have to do cosine of 4 plus 3x times the derivative of that inside shit, which in this case would be 3. So it's the derivative of the outside function, f prime, which in that case would be cosine, of this stuff times the derivative of the inside stuff. Well, that's just what you write, right? Since we don't have the actual information of what the function f is, we can't take its derivative. Sine is a function we know about. We know its derivative. We know all its derivatives. Anyway, how does this help us? Why is this good? Well, what happens to this value as x goes to 0? Like if this is going to be on our numerator now, remember, this thing is going to replace this thing, and then another thing is going to replace this thing. I'm sure you can do that. If this one makes sense, you can do the other one. What happens to those two things as x goes to 0? Okay, well, think if this is 0, and then it's f prime at 4 times 3. Do we know what f prime at 4 is? Is it the same as f at 4? No, it's not. It's different. So use that information. Now your numerator shouldn't be a 0 anymore, and it shouldn't be infinity. And your denominator, I'm sure by now you can all take the derivative of the denominator. And yeah, you should be good. So yeah, continue asking questions on the Facebook group. If there's anything you don't understand, let me know. I will help you out. And if you want me to personally help you pass your course, click in the description, open the YouTube video, click in the description, and join the mailing list, and I will get in touch with you for sure. All right, hope you're having an awesome day. Talk to you later.